Okay, topic 3.3 is more pyramids. We're going to work with triangular pyramids. We've been doing square pyramids. Now we're going to do a couple of different kind of pyramids. In this one, this is an equilateral triangle. Let's review some things that we know about an equilateral triangle. First of all, let's draw one. I'm going to draw it. I think I'm going to put it over here in the corner. And I want you to remember that in an equilateral triangle, if you draw the center point down, that's called the apothem. It's always at a right angle. It's always half of the side of the triangle, and it also creates a 30, 60, 90 triangle inside. So let's sketch that one. Let's see if we can find out some information using the pyramid here with the base. The regular triangular pyramid below has a slant height of 9. Now that's going to be this dark line right here. So I'm going to label it 9 centimeters. The base edge is 6, so that means the dotted line here. Well, wait a minute. That would mean that the slant height, the base edge is 6, so that means this piece is 3. Let's see if that's going to help us. Yeah, that's going to give you, let's go back over here. That means that half of each side is 3, because it's calling it the base edge. So we do, to find the apothem on this one, we're going to take the long leg, which is 3, and we're going to have to divide it by the square root of 3. I'm going to let you use a decimal on this, so let's do it in the calculator. 3 divided by the square root of 3 is 1.7. So the apothem on this one is 1.7. The picture over here, this is the apothem, so I'm going to go ahead and label it 1.7. Now you're going to have to use the Pythagorean Theorem to figure out the height of this pyramid. So let's do that. A squared plus b squared equals c squared. Your leg, we'll let the height be a. 1.7 squared, and 9 is my hypotenuse. If you see the little right triangle in here, 1.7 is the leg, 9 is the hypotenuse, and this dotted line going up to the vertex is the one I'm trying to figure out. So we have to use this Pythagorean theorem. So it's going to be a squared plus 1.7 squared is 2.89. 9 squared is 81. 81 subtract 2.89 is 78.11. When you square root that answer, oops, don't put the squared on that one. When you square root this answer, you get approximately 8.8. It's not an exact, but it's pretty close. About 8.8. So that is this right here is the height, because it's this dotted line going up, and it's the leg of our right triangle. Okay, let's do the lateral area. The lateral area, remember on the formula chart, is 1/2. Let's make sure I do this right. 1/2 perimeter times slant height. So you're going to do 1/2. Now, because of the tick marks, that means all the base edges are the same. So they're all going to be, this entire edge is 6. So you really have 6, 6, and the edge over here is 6. So the perimeter here is 6 times 3. So that's going to give you 18. And your slant height they gave us was 9. So the lateral area is 1/2 18 times 9. So that would be 81. let's see, did I do that? Yeah. So that's 81 of these centimeters, yeah, square centimeters. Your total surface area is the lateral area added to the base area. We haven't done that yet, have we? Alright, the base area on this one, let's see, you're going to have, let's see, oh, I'm sorry, I wasn't thinking. The regular polygon formula for area we're going to have to use on this one is 1/2 the perimeter times the apothem. So 1/2 the perimeter, 6 times 3 is 18, times the apothem, remember, was 1.7. Let me do that. 1/2 times 18 times 1.7. So 15.3 is the area of this base on your triangle. So when you do total surface area, you do the lateral area plus the base area. So we're going to add 15.3 to 81. That's 96.3 square centimeters. Let me write that on here. I forgot to put the total surface area formula is 1/2 perimeter times slant height plus the area of the base. And I had to use the area of a regular polygon to get the base area on this one. So that's how I got 96.3. Okay. The volume is going to be 1/3 the base area times the height. So this is 1/3 times 15.3 times, now the height here does not mean the slant height, it means the height of the pyramid, and remember we got that when we worked out the Pythagorean Theorem, so we're going to use 8.8. So it's 1/3 times 15.3 times 8.8. So that would be 44.88. Yeah, okay. And that's a cubic centimeter. Okay, let's try another one. The regular triangular pyramid below has a base edge of 12 and a slant height of 10. Find the area, find its lateral, total, and volume. Okay, this one didn't label anything either, so let's look at this like we did the other one. If your base edge is 12, half of that would be 6. So this piece right here is 6. I think it does help to draw the base separately, so I'm going to do that again. If you draw your base separately, we're going to look at this as the perimeter is going to have a 12, and then the entire side over here is 12 also. Now when you draw the apothem, it's a perpendicular bisector, so it turns this piece into a 6. Since it's the long leg of a 30, 60, 90, to get the short leg you divide by the square root of 3. So 6 divided by the square root of 3 is about 3.5. It's actually 3.46, but we'll round it to 3.5. So that is the apothem. So if I'm going to find the area of just this triangle, I'm going to use the 1/2 perimeter times apothem. 12 times 3 is 36. So it's going to be 1/2 36 times 3.5. which is 63. So 63 is the base area. And we're going to use that and when we do the volume. So we'll keep that. This is, let me write this over here. This is the area of your base. Okay. Now let's see what else we're going to need. That apothem is 3.5. And do we know the slant height? Yes, the slant height is 10. I'm going to just label that on here. 10 centimeters is your slant height. So if we use the Pythagorean Theorem, you have a squared plus 3.5 squared is equal to 10 squared. Oops, keep doing plus sign. So 3.5 squared is 12.25. 10 squared is 100. To solve for a squared, you subtract 12.25 on both sides. And that gives you a squared is equal to 87.75. So the square root of that is approximately 9.4. So 9.4 is, remember, I'm going to make a little note again like I did on the other one. This is our height. The height of the triangular pyramid is 9.4. So when we do the lateral area, we do 1/2 the perimeter times the slant height. So that's 1/2. The perimeter is 36, and the slant height they gave us to be 10. So it's 1/2 36 times 10. Let's make sure my math is right. Yes, 180. So the lateral area is 180 square centimeters. Your total area is always the lateral area plus one of the bases. So it's 180 plus, and remember up here, I just realized you're not seeing any of this. Let me move this up. Let me back up a minute. I didn't realize it was hidden. The lateral area is 1/2 the perimeter times the slant height. So it's 1/2 36 times 10 equals 180. And then, so your lateral area is 180. And then your base area is the area of the triangle, which remember we used the regular Polygon formula to do that, and we got 63. So you're going to add 63 to 180, which is approximately 243. And this would be square centimeters. Okay, one more formula. The volume formula is 1/3 the base area times the height. So it's 1/3. The base area was 63, and the height, now remember this h means the height of the pyramid. So the height of the pyramid is 9.4. And 1/3 times 63 times 9.4 is 197.4 cubic centimeters. Oops. 197.4. Okay, you might want to spend some time looking at that one. Let's move on to example 3. Okay, let's go back to, this is a square pyramid, and it's a description of the base edge is 10. Let's go ahead and label one of the base edges 10. That means that the line right here would be 5, because you always take half because it's in the center. It actually tells us that the lateral edge, and that's always one of the edges that's from the corner going up to the vertex. So be careful when you label this one. The lateral edge is 13. It does not mean the slant height, so don't pick the slant height to be your lateral edge. Let's see what we're going to need to do. 10, 5, yeah. Okay, if you notice, this part on a square is going to be 5, and this is a smaller line here, but it would also be 5 because your slant height is at a perpendicular bisector. So this slant height, I think I'll call it L. If we use the Pythagorean theorem, we're going to let that be the leg, and 5 is the other leg, and 13 is the hypotenuse. So I'm going to keep it L squared, I think. 25 is equal to 169. 169 subtract 25 is 144. So when you square root 144, you get 12. So that's your slant height. When you know your slant height and your edge right here, we're going to use the Pythagorean theorem again to figure out the height. I'm going to use h for height. So h squared plus the 5 squared would equal, now remember the slant height is 12. So if you notice, we're really using the Pythagorean theorem twice. We're going to have to figure out the slant height right here. So, I'm sorry, we're going to figure out the h. This is your height. So height squared plus 25 is equal to 144. If you take 144 and subtract 25, you get 119. So the height is the square root of 119. We're going to round that to the 10th, so it's about 10.9. So 10.9 is, this is your slant height, and this is your height. Okay, the other thing we're going to need is the perimeter. The perimeter of this one would be 4 times 10, so it's 40. And the area of this base is 10 times 10, so that's 100 square inches. So I think we have everything we need to use to find lateral area, total area, and volume. To do the lateral area, you probably memorized these formulas by now. You're going to do 1/2 perimeter times slant height. So that's 1/2. Remember the perimeter was 4 times 10, so that's 40. And your slant height was 12. Let me check my math. 1/2 times 40 times 12 is 240. These are inches, and it's area, so it's square inches. 240 square inches. That's your lateral area. To get your total area, you always do the lateral area plus one base, because you have one base. So our lateral area was 240. We add a base area of 100, and that makes 340. And this is an area also, so it's 340 square inches. Kind of going off the page here. Let me zoom out for a minute, make it a little bit easier. That might be too much. Yeah, maybe not. Okay, maybe that's better. I think that's better. Okay. Now the volume formula, since it's a pyramid, is 1/3 the base area times the height. 1/3 the base area of 100 and the height. Now this h, don't get it confused with the slant height. It means from the center of your pyramid, the base of your pyramid, up to the vertex point. And that height here is, we did kind of approximate, but it's 10.9. So this one was going to be, let's do the math, 1/3 times 100 times 10.9. My calculator is showing a repeating 3. I would like to talk about that. A repeating 3 means a third. So if we want to be really exact here, we would write 363.3 means a third, so we could write it as 363 1/3. But I think since we want to keep them in uniform decimals, we'll just do decimals. There you go. Example 3. Okay, one more for this unit, this topic. This might be one to review some vocabulary on the shape is a hexagon, 6 sides. It tells us that the regular hexagon pyramid below has a base edge of 4. I'm going to label this edge 4, but I'm going to divide this one into 2 2's, so you'll remember that we're probably going to have to use the Pythagorean Theorem. The slant height of this one is 6. Now the slant height on this one is this dark line. I think I'm going to, let me take my red pen. It always connects the midpoint of one of the sides up to the vertex. It's not like a lateral edge. Okay. It's actually not the same length. Alright, I think that might help you see it. That red line is the slant height. And my slant height here is 6. So let's just label this red line 6 centimeters. The base edge we already know. Now they want us to find the lateral area, the total area, and the volume. So we have the lateral, we need the height, we need the perimeter of the base, and the area of the base. Why don't we do that first? Let's do the perimeter and area of the base. Perimeter is probably the easiest one to do because hexagons have 6 sides and they're all 4s. When they use the word regular, that just means they're all the same. So your perimeter is 24. Now let's review how to figure out the area of a regular. I'm just going to write the formula. You're going to need the perimeter and the apothem. Remember, this A stands for the apothem. They've drawn this apothem right here, but I think for you to be able to see this a little easier, I think I'm going to need to draw it just to help you remember. We need to kind of look at it straight on so you can remember that the apothem is from the center to the midpoint of a side at a perpendicular. And if you remember, this angle, this triangle forms a 30, 60, 90 triangle. So if the short leg on a 30, 60, 90 is 2, then that means the long leg is 2 times the square root of 3. And that's just the properties of a 30, 60, 90 triangle. So that is your apothem on this one. So on this one you're going to do 1/2, 24 is the perimeter, and the apothem is 2 times the square root of 3. And I think I will turn that into a decimal. It just makes things a little bit easier. So 1/2 times 24 times 2 times the square root of 3. And that's about 41.6. And I am rounding because I'm using the square root of 3. Okay, we have our perimeter, we have our area, we already know the slant height, so what's left to get is the height, which is this dotted line going from the vertex to the center point here. Now the dotted line here is the apothem, and the apothem was 2 times the square root of 3. For now I think I'll leave it in radical form. I'll just show you, sometimes it's easier to do the Pythagorean Theorem with it in radical form. So let's go over here and do that. You have a leg, another leg that you don't know, and the hypotenuse. And the hypotenuse is the red line that's the slant height, so it's the 6. The apothem is the 2 times the square root of 3. I'll show you how to square that in the calculator. And then your other leg, we'll call that height, my A on my Pythagorean Theorem. So on this one, when you want to square a radical like this, 2 times the square root of 3, let me show you how to do that. You will have to start with a parenthesis and then put in 2 times the square root of 3. Because there's a parenthesis already created in the calculator, you're going to need to put a closing parenthesis and then one more, and then square it, and that way it'll square the product of those two. So when you square 2 times the square root of 3, you get 12. And 6 squared is 36. 36 subtract 12 is 24. So the square root of 24 is going to give us our height. Yes, it's about 4.9. It's 4.898. We'll round it to 4.9. So 4.9, what I did right here is I got the height. This is how I get the height. Let's write that up here. To find the height, you use the Pythagorean Theorem. So 4.9 is this distance from the base of the center point up to the vertex point. And I'm going to need that because I'm going to use that in these formulas. So let's now, let me draw a little line here. Let's do our formulas. The lateral area is 1/2 the perimeter times the slant height. So it's 1/2 times 24. And they gave us the slant height up in the beginning of this, and it was 6. So 1/2 times 24 times 6, let's check my math, is 72. So the lateral area is 72 square centimeters. For surface area, you use the lateral area and you add a base. So it's 72 plus, and let's go back and remember this right here was our base area. 41.6. Remember, we used the 1/2 perimeter times a Python. That's the formula for a regular polygon. So we're going to use our 41.6, and we're going to add that to our lateral area. That's 113.6. Okay, very good. Volume is 1/3 the base area times the height. So it's 1/3. The base area of this one, we'll go back up and use our 41.6. And the height is the height of the prism. That was this one, 4.9. I'm going to use my calculator to figure out the approximate answer. And it's approximately 67.9. I'll just check, make sure I did that right. Yeah. So 67.9 square, no, I'm sorry, cubic, we're doing volume. Cubic centimeters is the volume of this one. That was a lot of work. There are a few like this. If you see one in the notes and you'd like some extra help, just come see me.